All right, so here in this video, I'm continuing the discussion and how we can use R as a data visualization tool, right? So I've already mentioned that R is this very powerful and it's very versatile language. It's almost become ubiquitous with all of the sciences. Um, and you can use it for different reasons. Different. You can use it for variable reasons. Um, but the large reason that I use it more than anything else is for graphing. I do want to point out graphing in R is not inherently intuitive, right? This does take a lot of practice. It is tricky. For the bulk of my existence with R is that I've always had R open and a browser to help me answer every single little question that I have about R, asking how to run this line or that line, whatever. I'm always asking the internet of how to make R work. So that in itself is always a little bit tricky. Something I kind of left off, I didn't mention it, but every package, every function in R um, does have a help menu. So if I run a command, say R norm, but I don't know exactly how to use it, I can put a question mark in front of it and run it. It's gonna and the next thing that would be brought up in this right hand corner is a help menu, and it just kind of tells me what I'm inputting, how to specifically use that tool. And so every call has some degree of a help menu that should. I don't know if it's always. I don't always think our menus are always super helpful, but it is better than nothing, especially if you've had a little bit of practice and kind of know what you need to do, but have forgotten a specific detail or a specific option in this tool. So before the first thing that I wanted to introduce today is a generic data frame. Um, so R already comes with a handful of pre-installed data sets that you can practice with. Um, there are friendly. There are definitely two kinds of data sets. There are R-friendly data sets and not so R-friendly data sets that have to be manipulated a lot to make them R-friendly. Um, but for all intents and purposes, I won't ever give you or make you work with an R unfriendly data set because it's just too much work. Um, just that alone, making a data set that works as well as it can is already tough enough. So the first thing that I'm doing is introducing a generic data set. And so again, there are a handful of data sets already imported in R. One is Iris. Another is MT cars. Right. There are a handful others. I know there's more than that, and you can access a whole bunch of them online if you know what you're doing. Um, but today, I just wanted to practice with a biologically relevant data set that's Iris. So it's just this data Iris data set. And so whenever I just click Iris, it prints out whatever is in that data frame. But I can use data Iris to store that as a variable, as to basically import it into my terminal so that I can visualize it. So if I click this, I double click my data in my environment. My left hand side will change over to this upper right left pane will tell me what's in this data set. So every data frame, I mentioned that it's a data frame is a specific type of data structure um, that it's a simple matrix. So it has columns and it has rows. Um, this specific data set is from 1936. It's a Ronald Fisher data set, who was a statistician in the 1920s and 30s. But anyways, this is a relatively small data set, and it's used for more or less training purposes. There are 150 samples in here, and all of these are measurements of specific characteristics of 3 iris plant species. So for this specific individual, this sample, he measured out the sepal length, the sepal width, the petal width, and what species it is. So every sample has these um, 5 characters that were measured: species, sepal width, um, petal length, petal width, etc. And as I said, this is a generic training tool. And so data frames, again, they are a matrix. And whenever we work with matrices in either MATLAB or R, you can pull out specific rows. You can manipulate specific rows and columns. So if I do iris, I use my square brackets to say, so we're going to separate calling specific rows and then calling specific columns. So it's going to be row comma column. So for example, if I just want the first row, but I want the entire first row, I'm going to do row 1 comma nothing. And so that's just going to give me the metrics of the first row in this data set. But say I wanted the first column, I may do blank comma 1. And so that's going to give my entire first column and present it as a vector, as a linear vector. So this is one way to extract specific data from a data frame. And we can also recognize we can grab multiple rows and multiple columns. So how I would do that is that I would have my the starting row called, separated by a colon, and then the end row called. So let's say I want to pull out the first 6 rows. I'll do 1:6 comma nothing. And so that's just going to print out all the information about the first 6 rows. I think I can do the same thing if I do comma nothing 1 column. I'll say 3, 1:3. So that should pull out the first 3 rows, or sorry, first 3 columns of this data frame. Right. So this is just one way to access data. I think an easier way, and this is a little bit more common, I think it's a little bit more common, is to call a specific row title. So a column title. So you may not always, this data frame has these 6 columns in it. They all have titles, but you don't know necessarily which column number it is. Well, that doesn't have to matter as long as your columns have names. So if I wanted to call out a specific column, say I may do iris, and then I would pull up the iris data frame, and then if I want to call a specific row, I would do a $ and then that row name. So RStudio is nice, and it's way nicer than R, because it's once you pull up that $, then it will tell you what column names you could actually pull out. So I'll just pull out the sepal length. I'm going to do the data frame name, a $, and then the column name, and it's going to give me the same information if I did iris column 1, sorry, nothing column, what's that, sepal length 1. All right, so it gives me the exact same data. I just think it's a little bit more convenient to pull out the information based off of the column name. So for example, if I wanted to plot this data out just so I can look at it real quick, I've already introduced a couple of tools, the hist and the box plot. So I use a box plot because it summarizes distributions a little bit better. So I may do box plot iris dollar sepal. And so now that's going to give me a box plot. The median will be 6 centimeters. So all of these measurements are in centimeters, in the general distribution of the distribution of sepal lengths that were measured. Furthermore, I could also plot do a specific scatter plot or dot plot of this data from the RBase, um, I guess, catalog. So that would just be plot, and then I'm going to assign an x-axis. So that might be iris, dollar, say sepal width, and comma iris. In my second column, sorry, my y-axis would could be iris, dollar, sepal, and so that's going to pull up a scatter plot where the sepal length is on the x-axis and the sepal length is on the y-axis, and it plots those points out. So the base plotting tools are very handy for quick view of this data set, but it doesn't tell me, it's not as helpful as some packages in R. So this is one task that you will need to do, is to install the tidyverse R package. So anytime you install a new R package, there is a specific syntax to do that. So in this case, it would be install.packages and then the package name in quotes. So for this specific instance would be tidy, TIDYVRSE. Don't run that command now. It does take a while for it to install, and some other things you will be prompted for a couple of questions. Save this for a little bit, for later today or after you watch this video, not necessarily during this video. Um, but anyways, that's going to install a whole bunch of packages that are in this universe of packages that are used together frequently. Um, and honestly, tidyverse has its own, I guess, group of researchers that are really familiar with it. I'm not all that familiar with everything that tidyverse can do. However, I do need a specific plotting package that is wrapped up. It is its own standalone package. So you could do, it's called ggplot. So you could do an install.packages ggplot2. But if you do install packages tidyverse, it's going to go ahead and install ggplot and a handful of other packages along with it. So that's installing installing new packages that you don't have on your computer. But I do have these packages on my computer, and anytime I want to use them, I have to call them. And by calling them and importing them, I would use a library command. So a library, this case would be tidyverse, TIDY verse. So recognize that whenever you do an install packages, you have to put tidyverse in quotes. But if you do a library tidyverse, that tidyverse is not in quotes. But either way, anytime I want to use my ggplot or other tools that are in the tidyverse, I have to call in my tidy library tidyverse. And so that everything is uploaded now. And so now I have access to my ggplot library, tidyr, reader, per, dippler, etc. These are just additional packages that can make life a little bit easier if you invest the time to learn how to use them. Again, all that I'm really using, largely for the rest of the semester, is this ggplot2. So it's already installed, it's ready to go, and this is a very powerful graphical package. So I had this plain plot that really doesn't tell me a whole lot of information that I have just from the RBase. But ggplot can do the exact same thing and do it in a much better way. So if I want to make a graph, say make the same graph, this dot plot graph in ggplot, first I have to call ggplot. And this is going to be within parentheses. So everything that I need to call, specifically whenever I call this ggplot package, I have to call the data frame I want to use, and then I have to assign my x and y axes. So this common syntax is to call ggplot. I'm going to call iris, comma, and then to assign my x and y axes, I have to use this internal command called AES in parentheses. Within this AES I would assign x equals to this is what I say, sepal dot width, comma, y is equal to my sepal dot length. So recognize in ggplot, once I've told ggplot what data frame I'm using, I don't have to say iris $, column name. I can just throw in x column name 1 and y column name 2 and recognize the x and y have to be comma separated. But this command alone doesn't do anything except load in the data frame into this ggplot package. At that point, then I more or less tell ggplot how I want to present and plot this data out. So there is this, you would have to do a plus sign. So you're going to have this base command plus additional commands, and then any additional command on this line will be separated by a plus. And again, I was kind of talking about it earlier, but what's kind of going to happen is that I'm going to show you how to draw an owl, but when all is said and done, doesn't mean you're going to be able to draw any owl that you want to. And it is just because right, I can show you how to make a pen stroke, but it takes a lot of time, a lot of effort, a lot of thinking, and a lot of practice to make a painting. Right, and so that's kind of what's going to happen here. So we'll at least draw one picture out, and we can draw it in a few different flavors, but that doesn't mean you're going to be great at drawing with ggplot when all is said and done. This is largely an introduction to all of this. But moving on, so my ggplot, all the information will be imported and stored, and then I actually decide which graphing function I want to use. In this case, they all start out with geom something, geom underscore something. All of these plotting tools all start with geom something. So in this case, I want to do geom point. So geom point is basically the same thing. It's a scatter plot or a dot plot would be of the x and y data. So we should get effectively the exact same data, just plotted in a new way. So this is one thing that's really nice about ggplot is that it does have like these separators. So it has a grid. It has an internal grid. This may be a little bit tricky to see. I'm not sure, but I have an internal grid in the plot, so it kind of gives you a little bit more accurate estimation of where these individual plots are at. The x and y's are not inherently blackened, but we can make that happen. But where the real power of ggplot comes in is, again, this plot itself, it's no different from the plot we already made using just plot. Right, it's the exact same data, it's the exact same information, but what we can do is then add layers to this graph. We can draw on this even further. So for example, I can't remember, there's 3 different species in this data frame. So I have 3 different species, but I don't know which dot is from which species in this general plot. But ggplot allows me to visualize that. And it allows me to do that. I can do within my AES function. I think I can assign color will be equal to the species. And so the species again is just this column. So whatever is in this column, Setosa will get its own color, Versicolor will get its own color, and Virginica will get its own color whenever I say color is equal to species. Right, so I talked about in the last video of within some functions you will have to call an equal sign, and that's why I don't like assigning variables with an equal sign. You can do that, but it's poor syntax because you're going to use equal signs within other commands, and ggplot is a good example of that. But whenever I run that, hopefully everything will work. I won't get a complaint. And now my specific dots are color coded by species. Okay, so again, this may be a little tricky to see. I hope not, but I have a red, green, and blue. Hopefully nobody's colorblind. I'm sorry if you are. Um, but Setosa is in red, Versicolor is in green, and Virginica are in blue. Um, so now it helps us partition this data by color and makes it easier to visualize. Yeah, I think data visualization is really important in the sciences, but it also has this layer of art to it. Not everybody's going to tell you the best way to make a plot. Um, there is, subjectivity here, especially the better you get with it, and you can plot data out to make use different styles to build more uh, clearer graphs. And that's the whole point of data visualization, is to try to present the clearest graph that you can that explains most of the data, or at least finds patterns in these data. Again, it makes it just easier to look at. But what else I can do with this is, say I don't want to look at specifically this X and Y axis. I may want to look at everything. Say I want to look at different bar plots of, say, just sepal length. So in that case, I'm going to change my line. I'll leave this as species just in case. So my X will change to species. So what I'm going to do is build a box plot for the distribution of sepal length data points, but separate them out by species. So my species will be on the X, my sepal length will be on the Y, and I'm going to color code it by species. But since I'm going to use this as a box plot instead of a dot plot, I have to change my graph function from geom. Right, so now I have the distribution of my sepal links for each species, and it is color coded. It makes it very easy to look at and find differences, right? Clearly, Virginica has on average, has much larger, they're longer sepals than what we would find in Iris setosa. I think, well, let's see, this may get grumpy. I'm making stuff up here. I don't know if this will actually work. Nope. 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 I would have to look that one up to make a histogram, individual histograms for these. Let's see. I had this open already. Let me blah through. Oh, that's better. That worked. That kind of worked. Terror does not look good. Field by species. Genome histogram. Let's look at petal length. Petal length might maybe a little bit easier to look at. Okay. Right. So now we have distributions plotted out as a histogram individually for each species. So there's the distribution of as a histogram, the petal length for setosa, versicolor, and virginica. Maybe I'll take this one layer further and call in the really awesome thing about ggplot is being able to make multiple graphs of the same information at once using this geom a geom facet function. I think I can call that with facet grid by species. So squiggly line species. Let's see what happens. All right, so now I don't like that. Species squig complaining. Species squiggly line period. All right, so yeah, that worked. So I can separate and provide individual graphs for all three species that are all on the same x-axis and also on the same y-axis. So again, this makes it very easy to visualize information. Again, this is the huge advantage of ggplot over a lot of other graphing tools. I'm not saying there aren't good graphing tools. Python has some pretty good tools with matplotlib. but R is just, it takes, again, it takes a lot of practice, but if you invest the time to get good at this, you can make some very remarkable um, graphs uh, to present information. Um, and see, I have, there's just for an experiment. I can run this script that's a whole big script about plotting genomic information. We'll get to genomic information, but let's see. Just to demonstrate how flexible this is. Um, and I'll do fig 2. Right? So this is stuff I've already made. This is already stuff I've designed. But so I have 3 different transposable elements, lines, LTRs, and signs. And what I'm doing is that I'm comparing, um, say, a TE expression to how common it is in the genome. And I'm doing that for 3 different species and for 3 different types of lines. And I have my dots color coded based off of how old this kind of TE is. Is it really brand spanking new? Is it young and blue? Or is it green and old? And so what this graph pretty much shows is that for all species, for all TE types, expression strongly correlates with insertion number. So if I have a TE that's present 1,000 times, it's going to be more expressed than a TE family that's only present 100 times, right? So again, it just demonstrates some flexibility, and you can more or less make ggplot do whatever you want. You can change the background. How this whole line here, this is still all the code just to make this one graph. You're not going to have to do that, but nonetheless, it just demonstrates how powerful graphing can be done and how easy you can make multiple graphs all at once using uh, from one data frame. So I'm going to call it there, I think, and we'll pick up on Wednesday about how to put all these commands into a script and then just run it. So if you want to keep changing your graph, but you don't want to keep changing your commands all the time, um, or keep bringing up your commands all the time, um, that it'll be a little bit easier. So until Wednesday, I think that's it for now.